Hey, so today we're covering section 5 in chapter 2, and it's titled Solving for a Variable. You're going to think I'm crazy, but I really like this lesson. If you're into puzzles, problem solving, brain teasers, things like that, I think this one might be right up your alley. So what's going to look different today is that you're going to see equations that have a lot of variables in them, and we're supposed to solve the equation for a particular variable. So what you want to do, first locate the variable that you're trying to solve. Underline it, circle it, do something so you can see in your mind, okay, this is the one that I'm treating like a variable. Then just like when we solve a regular equation, you still have to figure out what operations are happening to it, and then use inverse operations to undo everything that you see. You're trying to still isolate that variable. So you're going to clear fractions, you're going to undo addition and subtraction, and then typically at the end you can have division if there's a coefficient still on that variable. These do take a lot of practice, so we will make sure that we're working together in class tomorrow after we've watched the video to make sure that we understand truly how to solve these equations. What you might hear these also called are literal equations. So if someone says, can you solve a literal equation? This is what we're doing. So again, it's an equation with more than one variable in it that we are supposed to solve for a particular variable. We start pretty easy and then they get a little more complicated. So the first one says, solve the following equation for R. Okay, this equation says D equals RT. This is actually an equation we use in physics. Distance equals rate times time. We don't need to worry about that. But what we do need to focus on is that currently this equation is solved for the letter D. It says D equals. We need it to say R equals because we're told here to solve it for R. So I do like to just kind of, make sure I know right where that variable is. I can locate it, and now I know what's being done to it, so I can undo it. Well, the only thing that's being done to the letter R here is it's being multiplied by t. So I need to undo multiplication by t, just like you would undo multiplying by 4. You would say, well, divide by 4. So how do I undo multiplying by t? I'm going to divide by t. And if I divide by t on the right side, then I have to divide by t on the left side. What happens on the right is that those t's are going to cancel out, and you're going to see that on the right-hand side, we are just left with r. On the right-hand side, we have d divided by t, and I can't do anything with this. I can't simplify it. I can't cancel anything. They're two different variables. There aren't numbers here that I actually can divide and get an answer, so r is going to equal d over t. Number 2, solve the following equation for m. That means we want m to be by itself. M minus n equals 5. So here we go. We locate m, there it is, and we look what's being done to it. Well, it has an n being subtracted from it. So I need to undo that. How do we undo subtraction? Through addition. So to get rid of minus n, just how you would get rid of minus 7 by adding 7, we want to add n to both sides. On the left-hand side, the n's are going to cancel, and I'm left with m equals. On the right-hand side, I have 5 plus n, and since n is a variable, those are not like terms. I cannot combine them, and so that's what I'm left with, 5 plus n. So m equals 5 plus n. We have the equation now solved for m. Number 3, solve the following equation for C. This is the formula to get from Celsius to Fahrenheit. That capital C stands for Celsius and the capital F stands for Fahrenheit. If you know a temperature in Celsius, you can convert it to Fahrenheit by using this equation. What we want to do, though, is solve this equation for C. Okay, right now it's solved for S. I need to solve it for C. I need it to say C equals at the end. So when I look at what's happening to it, I see that 9/5 is being multiplied by C, and I also see that 32 is being added to that term. We want to undo the addition, we want to undo the multiplication, just like we would with solving an equation. Notice in the steps that you wrote down earlier, we do undo addition and subtraction first, just like in a regular equation. So the first thing I'm going to do is take off that adding 32 by subtracting 32, and I need to subtract 32 from both sides. Okay, on the right-hand side, that cancels. Adding 32 and subtracting 32 would give me 0. On the on the left-hand side, excuse me, I just have f minus 32. I cannot combine those terms. They are not like. I don't know what f is at this point. So I just have f minus 32, and it equals what we were left with on the right-hand side, which is 9/5 c. Now remember from earlier, we can clear fractions if we want to here. You could multiply everything by 5, or if we recognize that's a fraction times the variable, then I'm just going to divide by that fraction. There are two methods to this, and I'm going to divide here by the fraction. On the right-hand side, those fractions are going to cancel out. Now, on the left-hand side, we would typically say, okay, we can't divide by a fraction, so you have to multiply by the reciprocal, and we would show what that would look like. And I am going to do that here, and I'm going to show you a couple of different things. But first, I want to say that I've got a c on the right-hand side, and I have f minus 32 all over 9/5 on the left-hand side. So I have this equation solved for c, but we can clean this up. Clean it up. So what does that look like? I'm going to ignore the equals c for just a moment so I can show you what happens. If I am dividing f minus 32 by 9/5, then I can multiply it by 5/9. So another way to write this would be 5/9 times f minus 32. This is actually how you oftentimes would see this equation when you have Fahrenheit and you want to get to Celsius. That's a lot of times how you would see it. I want you to recognize, though, how these two are, in fact, the same thing. You could also see it possibly with the 5 out in front here and the 9 actually on the bottom in the denominator. I've seen it this way as well. So then you would take Fahrenheit, your Fahrenheit temperature, you'd subtract 32, you would multiply it by 5, and then you would divide by 9. Same thing. So both of these, all three of these, are all equivalent. This one here is the most common way to see it. This is how it's written in textbooks. This is probably what your science teacher would tell you if you asked how to convert from Fahrenheit to Celsius. Okay, number 4, still getting more complicated because you can see a lot of variables, lots of operations. We want to solve that equation for W. So W is way up here in this numerator. How in the heck do we get that thing by itself? So S equals W minus 10E all over M. Now this is an equation where, because I see this fraction, I want to go ahead and get rid of the fraction. And I do that by multiplying both sides by what's in the denominator. Remember, we were working on equations like this back at the beginning of this unit, I think maybe in lesson 2, maybe even 3. There were some equations on the back that would have just a number on the bottom, a fraction on the other side where there's an expression up top. So these m's cancel. M times S is just that, M times S. You can write MS, you can write SM, it doesn't matter. And it equals W minus 10E. Remember, the M's canceled on the right-hand side. I'm still trying to solve for W. So right now I have a 10E being subtracted from W. This is like moving a term with a variable. I want to move the variable to the other side. I want to move the minus 10E to the other side. I'm going to do that by adding 10E to both sides. SM plus 10E. I can't do anything with that. I don't know what any of these variables are, so I'm just going to write SM plus 10E. They're not like terms, and it equals W. So now I have the equation solved for W. Solve the following equation for x. Y minus 4 equals 3x minus z. So you can see on the right-hand side there's a z being added to the 3x term, and there's a 3 that's being multiplied by the x. So we're going to have to undo subtraction of the z first by adding z to both sides. So I have y minus 4 plus z, and it equals 3x. Okay, y minus 4 plus z. I can't combine any of that. None of those are like terms. The 4 is a constant, and the other two, while they are both variables, they are not the same variable, so I can't put them together. Now I've got to get the 3 off of the x, and I do that by dividing both sides by 3. So I'm going to completely divide the left-hand side by 3, and I really can't do much with that either. I can't do y divided by 3 because I don't know what y is. I could write the negative 4 divided by 3 as maybe 1 1/3, but I don't want to mess with what all of that looks like. Let's just leave it. Y minus 4 plus z all over 3 is going to equal x. Now, if someone told you what y and z were, you could certainly plug those numbers in and then solve the equation for x. The last one, it says the formula for a triangle, and it's really the area formula for a triangle, is area equals 1/2 base times height, where b is the length of the base and h is the height. Solve for h. So I have currently the equation solved for area, and I want to solve it for the h. So I need to get rid of the 1/2, and I need to get rid of the b. They're both being multiplied by the h. So I'm going to have some division, and I also have a fraction, so I could get rid of the fraction. Remember that getting rid of a fraction, we can multiply both sides by the denominator. So I'm going to multiply this side by 2, I'm going to multiply this side by 2. So my half and my 2 cancel out. Remember, this is just one term, so I'm not multiplying 1/2 by 2 and b by 2 and h by 2. That's one term. There's no addition or subtraction separating those pieces. So on the left-hand side, I get 2a, and on the right-hand side, now I just have bh because 1/2 canceled with 2. I'm trying to solve for h, so I'm going to undo this multiplication by dividing both sides by b. That's going to cancel those out, and then I end up with 2a over b equals h. While you're working on these literal equations or solving for a variable, make sure that if the letters are capitalized, you're keeping them capitalized. If they're lowercase, please keep them lowercase. Capital A typically indicates area, so then we know here that we're looking for the area of that triangle first, versus making it a lowercase a. That's just not how we indicate area. So the plan is to work on worksheet 2.5 in class. I always tell students if there's ever a video I need you to do on time, it's this one, because we do a little bit of group work on this worksheet in class. If you have any questions, you can always reach out through email. If not, I will check these notes in class tomorrow.